Hello friends, myself Envi Lahamge, Assistant Professor, Department of Computer Science, MVP Samaj, Nasik.
In this video, we will see different DFA examples. In the first example, we have to design DFA such that it contains exactly 2 times C, means in all the string, whether at a first, last or middle position, we have to take C only 2 times, means we will try to design strings like A, B, C, B, B, A, B, C. Here you will see only 2 C's are there. So this is accepted string. You can get like also or or okay. These are some possible string combinations. So we will try to design them according to these combinations. First of all, we will start with one state, that is the start state. Then according to the logic, we have to count only 2 times C. So we will design logic for C first time. Okay. Then as we will see here that C's are counted only 2 times. So what will be the next steps for remaining A and B? So consider this is a DFA and we have to take each inputs transition to the next step. So from the set A, B, C, we had designed the state for C only. So what will be the case for AB? As we know that there is no any starting case, ending case or the middle case for such situation. So we will stop the A and B transitions to the state itself. Then for C we will take a one more. Then in this case for C we had done the transaction forward, but for Q1 again A and B comes, then we will stop them here. Then there may be case like another extra C will come in the scenario. So what we have to do in such situation? Simply discard the remaining C, means move it to the error state like this. Means when 2 times counting of C will be done, then if by chance any error string occurs and it will contain the whole number of times the C, then we will conformly pass it to the error state, means we will not give them entry in our DFA machine. So, and for the last state transaction, it can be having A and B. We will take one example and through which we will try to trace our string. Suppose A, B, C, B, A, B, C. This is the whole string in which it contains exactly 2 times C. What is our next job? We will have to tally it to our diagram. So when A comes, it will stop itself here. When B comes, it will stop here. When C comes, it will switch to the Q1. When again B comes, it will stop to itself. Again A comes, it will stop here. And when C comes, it will go to the Q2 state. And as according to the logic, we know that when the answer become a final state, is double circle state, our DFA will be accepted, otherwise it will be rejected. Suppose If we take here A again, means in whole string we will find only one time C. So this string not to be accepted by this machine. We will see when A comes stop to Q0, again to Q0. When C comes, it will goes to the Q1. When B comes, it will stop here. For another whole string, it will stop to Q1 itself. And as Q1 is not the final state of our machine, this string will not going to be accepted by our machine. This is all about the DFA for counting of string in which there is only two times occurrence of C. Next, we will take another example. Construct a DFA to accept all strings over 01. Means here in this case, what is the alphabet set? That is the 0 and 1, in which every position in the string is occupied by even position by 0 and odd position by 1. Means you have to take positions like where you will count your string. Suppose there are 1, 2, 3, 4, 5, 6 digits or symbols in your string. Then according to our even odd logic, even positions are 2, 4 and 6. Then at these positions there will be always 0, and for these odd positions there will be occurrence of 1 in the given string. So we will try to design such a machine. In such case, we will have to make two states, as one for even and one for odd and another for the error state. Means suppose Q0 is a state and in which any one input comes like from 0 or 1. If in such case 1 comes, it will pass to the next state, and when 1 is reaching to the another state, make that state as a odd number holding state, and when you will transition to the next state, and at that case you will come at the 0, means 0 alphabet will be there. Then in such case transfer it to the Q0, means it is the even number holding state. Means we are making this state as a even holding state and this state as a odd position holding state. You can reverse both the states and manage the flow of the input alphabet in such a diagram. Here in this case we had covered only the 1 and 0 for both the states, means only single alphabet. But what about the next remaining alphabets? When 1 comes, it will be transferred to the Q1. Means here you are flowing or you are giving the flow for only the odd number situation holding, and for 0 we will make another step. Make it as a Q error or you can make it Q2 also. And for here as it is a even transferring, transfer the 1 to this stage, and for this remaining 0 and 1 will be dropped to the same state. Now we will try to trace our machine through taking one example. Suppose 1, 2, 3, 4, 5 and 6. Consider this 6 length string. As according to our DFA logic, we will have to accept zeros at the even positions and 1 at the odd positions. Means place 1 at these odd positions and zeros to the even positions, and try to trace out this through our DFA. Now when 1 comes, it will goes to the Q1 state. Again when 0 comes, it will comes to the Q0 state. Again 1 comes, it will goes to the Q1. Again 0 comes, it will comes to the Q0. Again 1 comes, it will shift to the Q1. Again 0, it will comes to the Q0. As we are seeing here that in this situation 0 is transferred at last to the state that is known as a Q0 state, and it is the final state. One question will arise while solving this problem in our mind that why we had made two states to the final states. Consider one case. Here we had taken total 6 digits, means at the end even number will be arrived. There may be case like we will add some 7 number digit and we'll take at a 1 at that position. Then in such situation we will not have to worry about the total length of the string, but only the positions, means even positions will accept only zeros and odd positions will accept only ones. So this is the logic behind solving DFA, to construct a language in that all even positions hold the zero alphabet and odd positions contain the one alphabet.